Good morning everyone. Welcome to this session. In this session we are going to discuss about normalization, why we need normalization, what are all the advantages and disadvantages, and what are all the types of normalization. So these are all things going to be covered in this session. First thing, the need of normalization. So when we are just handling the large database and we are just maintaining a single relations, so that it may lead to the duplications. So due to this duplications or repetition, so we may get some uh, problems. The first thing, the making a relationships is a very large thing, and it is not easy to maintain or as well as updating the data. Some data it may be missed out, so due to that wastage and then pure utilization of the disk spaces and then some resources we can able to achieve, and sometimes the errors and inconsistency of data it may be increased. So to handling these problems, so we should analyze as well as we have to decompose the relationship with the redundant data into the smaller pieces of the table. So to satisfy this desirable problem, to satisfy these things, so we are just going for the normalization. What is normalization? It's a very simple process. It's a process of decomposing the relations into relation with fewer attributes. If our database it's contained the n number of the attributes, clearly the 10, 20, more than that. So that time we are just making the relations and then maintaining the functional dependencies are very difficult. So at that time we are just decomposing the relations between that attributes. It's a organizing session of the data in the database, that is called as a normalization. So it helps us to minimizing the redundancy as well as when we are just doing the anomalies, insertion anomalies, updation, deletion anomalies, at that time it is going to be reducing the error rates. So it divides a larger table into the smaller pieces, and we are just making the relationship a bit among with these smaller tables. So it is a normal form. It is used to reducing the redundancy from the database table. So these are all the advantages and then disadvantages normalization. So first, it is minimizing the redundancy, and it is overall a database organization is a well and good, and data inconsistency it's going to be avoided, and more flexible as well as the relational integrity is going to be increased. When we come to the disadvantage, we can't able to divide as it is. So first we want to know about the user's need, then we can able to do that. And when we are just going for the normalization, the higher levels, 4 enough, 5 enough, in that like that, so we need to do the analysis depth, without simply we can't able to apply those things. It's need some knowledge. It is very time consuming as well as difficult to normalize the relations of in the higher degrees like 4NF and then 5NF. When we are just applying the careless decomposing, so obviously it is lead to the error. Some data it may be a loss. So due to that we will lead to the some serious problems. So these are all the disadvantages. So when it comes to the types of normalization, these are all the types. First normalization, second, third, Boy's code normalization, fourth normal form, and then fifth. So then we can see one by one. If we are just going into the third normalization form, in the sense each and every order it should be satisfying the previous level of the condition, then only we can able to apply. So directly we can't able to apply for the third normalization. If we are just applying the third normalization form, it should satisfy the condition for the second normalization. Like that, the level by level all the normalization forms we can able to apply. So now we can see one by one. The following the various types of attributes is there. So the conditions of the each and every normalization. So first thing, it is eliminating the repeating the groups, and second one, it is help us to eliminating the partial functional dependencies, And third normalization form, it is eliminating the transitive dependencies. And then fourth one, it is a multi-value dependencies, eliminating the multi-value dependencies. And then fifth one, eliminating the joint dependency. So when we are just applying the decomposition of these relations, obviously we can able to reduce the redundancy. Redundancy is going to be reduced. So the meanwhile, the two things is going to be increasing. The first one, uh, um, number of table is going to be increased. So we whenever we are just decomposing, so the large table we are going to be divided as a smaller part, so the large one it is making to as a 2 or 3 more tables, so number of tables going to be increasing. Obviously the complexity also it's going to be increasing. So these are the things we need to take care when we are just applying the normalization form. First, normalization. So the condition. And what is first normalization form in the sense? The table to be considered in a first normalization in the sense, all the field it should contain only the atomic values. That means it is a scalar value. So it's a unique values. It's not more than one value. So that is a condition we have to construct according to that. If we are just taking if any one table holding the multiple values, so that should be eliminated. So to avoiding that, according to that we need to construct the values. So in this table it's showing as a book informations, title, author name and phone number, and the publication name and publication phone, price, and etc. If you are just saying this two columns, author name and then author phone number, it's more than one, it may be applicable for particular book. So it's not compulsion only one author, more than one author may be present, so everyone having the individual phone number. So this is not under the first normalization form. The condition is all the relation, it's one enough if we are satisfying means it should contain the atomic value. So what we can do it, so we need to apply the decomposition. So how we can do the decomposition here? So we are just placing the all items appearing in the repeating the groups that we are just maintaining as a new table. So now we are just taken that author name and then phone number. So which one is repeating? So these things, and then ISBN is a primary key. So it is an indication of those things. So that we are also making as a another table. So now ISBN number, author name, author phone number is a one table. And remaining attributes we are just keeping as a another table. So like that we can able to decompose it. So now if we are just saying, so there is no attributes is contain more than one value. So each and every row is containing the unique value. So like that we can apply. And we are just come to the second normalization form. The first condition we already discussed. So whenever we are just going for the normalization, it should satisfy the previous normalization condition. So if you are just going for the second normalization forms, so first condition, it should, the database must be in a first normalization form, and then all the non-key attributes in the table must be functionally dependent on the entire primary key. So here we are dealing with only the non-key attributes. For in this example, the schema is title, publication ID, author ID, prices, and then author address. Here the key values we are just taking as a title, publication ID, and author ID is a key. So remaining two things, the price and then author address, is a non-key attributes. So now the price is dependent on the title, publication ID, author ID, and similarly author address is dependent on the author ID. So here author address does not belongs to any key. So author address is functionally depend on the author ID. So it is a subset of the key. So that is the condition it's violating. It is not under the 2NF. So the second condition, all the non-key attributes table must be functionally dependent on the entire the primary key. So now we need to avoid these things. So how the decomposition will be applied here? If a data item is fully functionally dependent on only the part of the primary key in the sense, so we have to move that data item and the part of the primary key, so enter as a separate table. So in the previous example, we see here the author address is functionally dependent on the author ID. So now we are just considering that as a new table. So our new schema, author ID and then author address is a one table, and remaining thing we are just going to be make it as a another table. So like that we are just decomposing the original schema into the two tables. So another example, if you are seeing here, city, street, house number, color and city population. Here the key values are city, street and house number. So the color is dependent on city, street and house number. Similarly, city population is dependent on the city. So now we came to know how to decompose it. So city population does not belong to any key, but it is totally functionally dependent on the city. So now we can apply the decomposition like this. City and city population is a one table, and remaining attributes we can make it as a another table. So I hope now you can understand. So one more example if you want. Studio, movie, budget and studio city. So here the key attributes are studio and movie, and budget is dependent on studio and movie, and studio city is only depend on the studio. It's not depend on movie. So now you can decompose it as a studio and studio city as a one schema, and remaining attributes we can make it as a another schema. So this is a way we need to decompose if we have to satisfy the 2NF. Now 3NF. So this is the form dedicating that all non-key attributes of the table must functionally dependent on the candidate key. That means there is no interdependencies among the non-key attributes. The conditions, if we are just going in the sense, the first condition, obviously the table should satisfy the second normalization form, and no attribute it's having the transitive dependency on the primary. Transitive dependency in the sense A tends to B and B tends to C, in the sense obviously it is transitively A tends to C. It is true. That is a transitive dependency. So there is no interdependencies among the non-key attributes. So if it is a non-key attributes having the interdependency, obviously it is leading to the transitive dependency, A to B, B to C. So implicitly A to C is also true if it is A is a primary key. So now we can see in this example, the schema is title, publication ID, page count and then price. So now the key attribute is title and then publication ID. The page count is dependent on title and publication ID, and price is dependent on the page count. So here both price and then page count dependent on the key. So then it is satisfying the 2NF. And transitive dependency, title and publication ID, it depends on the price. The prices depend on the title and publication ID. So hence it is not in a 3NF. We can able to get the transitive dependency here. So how we can avoid these things? So we are moving all the items involved in a transitive dependency in a new entity. So now we have to identify a primary key for the new entity, new subset, and that you can make it as a foreign key, and we have the making the relationship with the original things. Now we are just converting into 3NF means we are just decomposing publication ID, page count and price is a one schema, and then title, publication ID and then page count. That's another schema. So now there is no transitive dependencies between the attributes. So if you are seeing this studio, studio city and city temperature, studio is a key attribute here. and city is dependent on studio, and city temperature is dependent on studio city. So it is implicitly city temperature is depend on studio. So here we are attempting the transitive dependency. So it is violating the 3NF. Now we have to convert that as a decomposition. So now studio and studio city and then city temperature. In this schema, we are identifying the studio city as a primary key. So we are just making this a new primary key. Then we are just applying the relationship between these two tables. So like that, we have to identify the we have to apply the apply the decomposition to avoiding the transitive dependency on the non-key attributes. So one more example again, building ID, contractor and then fee. So here building ID is the key attribute. The contractor is dependent on building ID and fee is dependent on contractor. So it is implicitly building ID is it's having the relationship to the fee. So here fee is transitively dependent on our primary key. So we are just decomposing like this. Building ID, contractor is a one table and contractor and then fee is a another table. So here first schema building ID is a primary key and second schema the contractor is a primary key. And Boy's code normalization form, so it is called as a BCNF. It does not allow the dependencies between the attributes that belongs to the candidate's key. So first we have to get the differentiation between the third normalization form and BCNF. Both are not same. So these are the difference. The table has two or more candidates key here. At least the two candidate keys are composed more than one attribute. So the keys are not disjoint. It is a compositive candidate keys that sharing some common attributes. So if you are seeing with the example, city, street and zip code. Here two set of the keys are there. City and street is a one key and another key is a zip code and then street. So no non-key attribute here. So hence it is satisfying the 3NF. But city, street. So zip code is dependent on city and street. Similarly, city is dependent on zip code. So the dependency between the attributes belongs to the key. So both are key. So city is also one key and zip code is another key. Now city is depending on the another key attributes. So now here it is violating the BCNF. So how we can apply the decomposition here? So the place of the two candidate primary key in separate entities and place the each of the remaining data item as in a one result of the entities according to its dependency on the primary key. So now how we can divide that into the two in the sense city, street, zip code. For example, now if we are just dividing the schema like this, zip code and street is a one table and city and street is the another table in the sense. Now again what will happen? The relationship between the city and zip code is going to be lost because the zip code, that is a pin code, is always dependent. City is always dependent on the pin code only. If you are just dividing this kind of the two schemas, obviously this relation, this data is going to be lost. So that is wrong thing. So we are just going to be making loss of this relation zip code and then city. So then how we can resolve this problem in the sense we have to divide like this, zip code and street and zip code and city. So now street is dependent on zip code as well as city is also dependent on zip code. If we are just dividing like this in the sense, we can lead the loss of relations. So that also we need to take care. So we need to avoid the lossless decomposition always. When we are just applying the decomposition, we have to ensure the lossless decomposition. So we have to apply zip code and street and zip code and city. This is the right schema. And one more example. Movie title, movie ID, person name and role and payment. Here the key attributes are first key, title and name is the one key attribute, and ID is the person name is the another key attribute. Here movie title is dependent on movie ID. So obviously it is violating the BCNF. So how we can decompose it in the sense? We can apply like this. Suppose if we are just making like this means again movie ID and then title, this relation loss will be there. So instead of that, we have to apply movie ID, name, role, payment is a one schema, and another schema ID and then title. Like that we can able to make it. So the next one, fourth normalization. So fourth normalization, it's eliminating the independent many to one relationship between the columns. So if you want to satisfy the fourth normalization, obviously it must satisfy the BCNF characteristics, and it may not contain the more than one multi-value attributes. In this example, the schema, it may be a movie name, city and genre, and here all these things we are just taking as a key attributes. So all the columns, the part of only the candidate key, so it is satisfying the BCNF. But many movies can have the same genre, and then many cities may have the same movies. So it is violating the fourth NF, that is many to one relationship is there. So how the decomposition it is going to be applied? We are moving the two multi-value relation to as a separate tables, and then we are just identifying a primary key and for the new entity. So now the schema, name, city and genre. So now that we are dividing as a two things, movie name and city, and then movie name and genre. So like that if we are just dividing, so we can avoid the many to one relationship among the attributes. So another example, if we are just seeing employee name, skill and foreign language. So here one employee may have more than one foreign languages, they know this thing, and similarly so they may have the more than one skills too. If we are just saying this first employee having the cooking skill and then two different knowledge languages, and then similarly you can able to apply for the remaining employees too. So how these thing is going to be apply in a decomposition in the sense employee and skills and employee and then foreign languages, like this. So the next one, fifth normalization. So fifth normalization, it's satisfying when all the tables are broken into the many table as much as possible to avoiding the redundancy. That's it. So it is further we can't able to broken down as a smaller into up to that level we have to divide the tables. For example, here the three columns, traveling, salesman and brand and then product, so that we can able to divide as much as possible in the sense. So the three columns, here the salesman it's a primary if you can take it, so the salesman and brand is a one table, and then salesman and then product type is a another table. So like that here the three attributes, so we can able to make it as a true, and similarly if it is a 6 attributes or 7 attributes, you have to make it as a as much as smaller, further we can't able to divide anything. So in up to that level we have to apply. So that is your fifth normalization form. So all these things we can't able to apply for all kind of the scenario. So based on the our database functional dependency, which normalization form is applicable for our scenario, so we can take it and then apply. Thank you.